Okay, on to question 12, the complex number question. For part A, I'm asked to show that w, this number here, is a root of the equation z to the 5 minus 1 is 0. So I really want to show that this to the power of 5 is equal to 1. So w to the power of 5, set that up. I'm going to use de Moivre's theorem here to the power multiplies the angle. So w to the 5 is cos 2 pi I sine 2 pi, which is 1. So w to the 5 minus 1 is 0. Therefore, w is a root as required. So just make sure that your logic is clear in there. For part B, he then has to show a result. So I'll do that. Again, it's a show that, so I've got to make sure I can see that the marker knows that I've gone through those steps. So I can do all of that. So that's the result as required. And then deduce that this second factor is equal to 0. Well, we know from before that w to the 5 minus 1 is 0. We know that w to the 5 factorizes to be this. We know that w minus 1 is not 0. Therefore, this second factor must be 0. So there are my steps for part B. And for part C then, hence show that. Now, I particularly like the use of diagrams for these questions. So I know that w is one of the fifth roots of unity. So all of these things are arranged around the Argand diagram like this. This is an Argand diagram, so the imaginary there and the real here. I know that this first root is 2 pi on 5 I sine 2 pi on 5, and I'm going to exploit the symmetry. I know that w to the 4 then has got the same real part, but minus I sine 2 pi on 5. The reason I'm doing this, I want everything to be in terms of sine 2 pi on 5, or 4 pi on 5, because that's the result I'm trying to show. This second root, I know that that angle is 4 pi on 5. So I've got that result for the second one, for w squared. I know that then by the geometry of this, that this root here, w cubed, it's got the same real part, cos 4 pi on 5, and the imaginary part is the negative minus sine 4 pi on 5. What I can then do when I add these up, I can see that if I sum these, I've got 2 cos 2 pi on 5, so add all these up, plus 2 cos 4 pi on 5. I can see here that these cancel out nicely. So I've got that. We already know from before that the sum of that will equal to minus 1. And then I've got one step to go. Here we go, I'm almost there. I've got cos 2 pi on 5 plus cos 4 pi on 5 is therefore equal to minus a half. And I've got it.